Welcome. This is lab number 22, crashing cars. I've mocked up what this lab looks like, where a red car will knock into a blue car with some photo gates in between them to pick up what is their initial velocities. And from that, we are going to be measuring what is the final velocities and looking for some sort of patterns between how we might predict what is the final velocities of some cars that are involved in a crash. So I've mocked that up over here. As you can see, I've got the LabQuest device, and it's going to be measuring how fast are the cars going to be going. And so the setup will look like something like this. As what we're calling the red car comes along and it first passes through this first gate, it'll measure what the velocity is, and then after the crash it'll continue on and we'll measure what did the velocity, what was the final velocity. So in this case we'll be able to know the initial velocity of the first car. We'll know that the second car will start from rest, and then after they crash and they get stuck together, we'll be able to find out what is the final velocity. So usually when we do this lab, we would be able to pull the data from here and look at what are the numbers for the final velocity, and then we would construct a momentum table. And from the momentum table, we would be able to look for some sort of patterns. So what was expected is that we would fill out a table like this one, and as we write down the numbers for how much is the mass and velocity, the momentum, and what's the kinetic energy, we'll notice some patterns, such as if it's a bouncy collision, then we'll see that the total momentum and the total kinetic energy would be the same before and after. But if it was a sticky collision, then in that case it would only be the total momentums that'll be the same, but the kinetic energy would actually go down in that case. So we would track that on here. But unfortunately, since you guys can't interact with this lab equipment today, then I'll just kind of share what the resulting model will be. And so the rest of this video is going to be a demonstration for how, once we discover what that working model is, and using momentum, I'll show how it is that we can model other collisions that are taking place and calculate how much is the momentum to be able to predict what's going to be the final velocity of some object involved in a collision. So anyways, stand by for a second. Just stand by, and I'm going to set up my whiteboard. Almost. I'm still kind of working out all the details for how to best set this stuff up, so I appreciate your patience. Anyway, so I think that's going to work out just fine. Let's try this out, huh? So anyways, this working model is going to be a way for us to show how much is going to be the mass, the velocity, and momentum before and after a crash. So I'll plug in some numbers into here, and we'll practice calculating how much is the momentum going to be, and we'll use that to ultimately try to determine what's going to be the final velocity of this blue car after the crash. So in order to fill out this momentum table, we'll start by taking a look at the drawing, and we'll interpret the drawing to show the numbers inside the box are going to represent how much is the mass. So from this, we'll be able to see the red car has a mass of 5 before the crash. The blue car has a mass of 2 before the crash. And then after the crash, we'll assume that they maintain the same mass. There's no mass being transferred. And so if the red car had a mass of 5 before the crash, it'll have a mass of 5 after the crash. Even though it doesn't say that number, we can predict that's what it's going to be. And the same thing for the blue car now. So if the blue car was 2 before, then the mass of the blue car will remain 2 after the crash. Next, we'll write down the numbers for the velocity, indicated by the arrows. So we're following the convention where if it's going to the right, it's positive. If it's going to the left, it's negative. For this first one, the red car is shown to have a velocity of positive 3. The blue car's velocity is 0. And then after the crash, the red car has a velocity of 1. And the blue car's velocity is what we're trying to find out. So the whole purpose of doing this model is so that we can predict the future. In this case, that is the future condition we want to find out. How fast will the blue car be going after the crash occurs? So far we have some numbers in terms of the mass and velocity. The new concept for this week is going to be about momentum. And the way we would calculate how much is the momentum is by multiplying the mass times the velocity. So in this case, a mass of 5 times a velocity of 3 will be a momentum of 15. For the blue car, the initial momentum would be 2 times 0, which is 0. And then after the crash, the red car will have a momentum of 5 times 1, which is 5. And the momentum of the blue car after the crash, we don't know because we don't know the velocity. But don't worry, we're going to work backwards, applying some other concepts involving what is the total momentum. So if we were to do this lab, and like I was saying earlier, we would discover how the total momentum before the crash should be equal to the total momentum after the crash. And we'll calculate how much is the total momentum down here. So down here, we'll see that the total momentum is calculated by adding these two momentum values together. So 15 plus 0 is 15. And as soon as you know the total momentum, then we can apply that condition before to also be the same condition afterwards. So during a collision, what we'll discover from this lab is that the total momentum will remain constant. And so for that reason, if it was 15 momentum before, it will be 15 momentum afterwards. And now we can work backwards using that same momentum equation of saying P1 plus P2. In this case, if the P1 was 5, then how much would this P2 have to be so that the total momentum is 15? If you're not sure, you can take 15 minus 5, or you might guess, what number would you add to 5 to get that total of 15? So in this case, the number is going to be 10. And now that we know that the momentum of that blue car was 10, we can use it to find out how fast is that blue car going to be going. The mass is 2, the momentum is 10. 2 times some velocity number is going to be equal to the momentum of 10. So you could probably guess that this is going to be the number 5. If you're not sure, then you can just take the momentum divided by the mass as working backwards from the momentum equation. And that's how you would find out how much is the velocity. And it looks like we're pretty much done. The last thing we want to do is to put this on our diagram. So if we found that the velocity was 5, then we would mark that as the number 5 over here for the velocity. So if you can get that done, that's the big objective for the week, and you can get the full points for the assignment. Thanks, bye.